Welcome to the video on Pythagoras Theorem, finding a missing side. Now if you've gone through the notes so far, you'll have been practicing finding a side when you've been given two sides in a right-angled triangle. You must remember Pythagoras only works for right-angled triangles. So for example, if we had the standard triangle, we're told it's right-angled and we have sides of 3 and 4. Then to find the hypotenuse, the longest side, we would do 3 squared plus 4 squared equals, and you would get an answer of 9 plus 16, which equals 25. And to find the side, we need to square root that answer. So the square root of 25 is 5. Now, if we're looking for a side rather than the hypotenuse, the technique is the same. So if I take that one, if I say we are looking for the bottom side there, we would have the hypotenuse squared, take away one of the side we know squared, equals the side we're looking for. So we've got 25 take away 9 is 16, and that's the square. We need the original number. So it's the square root of 16, which gives us the side of 4. Now, sometimes you'll get questions that are very obviously a right angle that you're looking at, and it's obvious to spot that it's a Pythagoras question. However, in the exam, they are more likely to give you a triangle hiding inside a circle. This question is taken from the 2018 paper 2, and it's question 12. Let me get the wording up. The shape below is part of a circle, centre O. The circle has radius 13 centimetres, AB is a chord of length 20 centimetres, and we're asked to calculate the width of the shape. Now when we cover circles, I'll explain what all that is. You may know some of it already, but I just want to quickly show you what's going to happen. A radius goes from the centre to the outside edge of a circle. So we're going to take that to one of our points. We're looking for the distance here, and we also have a radius on this side, and that radius will be our 13. This one will be a 13, and we're looking for this unknown here. I'm going to call x. And because of the quirks of circles and chords that split circles, we will have a right angle there. We're told that AB is 20 centimetres. So we're going halfway. We've got a perpendicular bisector. Again, we'll come to that when we deal with the circles. So that means it splits AB perfectly in half, which gives us 10 centimetres there. So I'll quickly redraw this so you've got an idea of what we're dealing with. We've got a right-angled triangle, we've got an unknown side, we've got a side of 10, and we've got a hypotenuse of 13. So we're going to use the information in our formula. So we have 13 squared minus 10 squared, because we're looking for a side and we've been given the hypotenuse. It's hypotenuse squared, take away the side squared, and we're going to see what that gives us. I'll bring it down this way. We've got 169 for 13 squared minus 100 for 10 squared. 13 squared is one of those famous ones. You start spotting them in the questions quite regularly. So 169 take 100 is 69. And what we're actually looking for x is the square root of 69. Now, unfortunately, that is not a nice number. What we get there is 8 and a bit. We get 8.3066238692 on the calculator. We're not interested in most of these numbers though, because here we're dealing in whole centimetres. So it's reasonable to give it back either as whole centimetres or to 1 decimal place. So I'm going to give it as x is approximately equal, so that's the wiggly equals sign, to 8.3 rounded to 1 decimal place. Now in an exam, it's a good idea to write out that number that your calculator gives you as well as your rounded answer. Sometimes they're very picky about giving you your answer. You have to show the unrounded one because they're testing to see how well you round.